there, everybody. Welcome to your review for the upcoming Chapter 6 test. Chapter 6 has covered rates, ratios, unit rates, and proportions. So we're going to go over everything you might possibly see on the test, and then any areas that feel a little confusing or fuzzy, I want you to practice on your own or come see me in the Math Center so we can practice together. So without further ado, let's jump right in. The first question is asking us to write each ratio or rate as a fraction. And I want to point out the important piece of this is that it's asking for it in simplest form. Now, when I'm writing my rate or unit rate as a fraction, we cannot have any decimals or fractions within the final rate. So here's how we're going to approach this. For our first one, our ratio is 4.25 yards to 8.75 yards. So we start with the first measurement on the top and the second one on the bottom. But we're not done because first of all, I see that I have decimals within my ratio and it's not in its simplest form. When we have decimals within a ratio, we have to remove the decimal. We have to move it out of the problem. And in doing so, we have to make sure we keep the ratio equivalent to the original problem. So to do that, I'm going to move my decimal until I have a whole number. So for my first one, 4.25, I have to move my decimal 2 places. Now, whatever I do to one side of my ratio, I have to do the exact same to the other. So I'm going to move this one also 2 places. So now my ratio is 425 over 875. I've gotten rid of the decimals. Now I just have to simplify. So I see that they both end in multiples of 25. So I'm going to start by just dividing by 25 and I get 17 prime numbers. So that seems to be the most I can simplify this. And then I'm going to divide 875 by 25. So we divided both of these by 25 and we get 17 over 35. So that would be my final simplified ratio. Now I want to point something out. Let's say our ratio was 4.6 over 7.23. Now in this scenario, we have a different number of decimal places, but we still need to make sure we're keeping our fraction or ratio equivalent. So I'm going to look at the number with the most decimal places and see how many times I have to move that decimal point. In this case, it's 2 times. So because I want to keep things equivalent, I have to do the same to the other piece of my ratio. So I'm going to move this decimal 2 times. And then if I have any missing place values or empty place values, I'm going to fill it in with a 0. So this would become 460 over 723. Okay, so let's move on to a ratio with mixed numbers and fractions within it. The first thing I'm going to do is set up my ratio. So 2 1/4 to 4 3/8. So I'll put 2 1/4 on the top and 4 3/8 down below. But I can't leave it like this because right now I've got a fraction within a ratio. So I want to remember that when we are talking about fractions, that is actually division. So for this problem, we would rewrite it as 2 1/4 divided by 4 3/8. Now notice I'm no longer in a fraction form. From here, I am going to follow my rules of our fraction operations. So first I'm going to make these into improper fractions. So 9 over 4 divided by 35 over 8. Then we keep change flip. So 9 over 4 times 8 over 35. Don't forget your keep, change, flip. Then we can simplify. So 9 and 35, they can't be divided by the same number, but 4 and 8 can. 4 divided by 4 is 1, 8 divided by 4 is 2. Now we can simplify and we get 18 over 35. That would be my final fully simplified ratio. It is very important that we are following these steps and then making sure to simplify as much as we can. Next up, let's write our rates as a fraction in simplest form, but this time it's given to us in more of a word form. So the first rate is 6,000 people to 2,400 pets. So 6,000 people, I want to label my units, to 2,400 pets. Now from here, I want to simplify this. They didn't say unit rate, so I don't need to get my denominator to a 1, but I do want to simplify as much as I can. First thing I notice is I have zeros that cancel out. So this becomes 60 over 24. And then these can both be divided by 12. So that will give us 5 over 2. So 5 people to 2 pets. Okay, let's try another one. 15 pages printed in 6 minutes. So that's 15 pages divided by 6 minutes. Now, I want to simplify. My fraction, or ratio as we're calling it in this chapter, is 15 over 6. These can both be divided by 3. And when I do that, 15 divided by 3 is 5. 6 divided by 3 is 2. So 5 pages in 2 minutes. All right, now the next question asks us to write our rates as a unit rate. So the thing we want to remember here is for a unit rate, our denominator must be 1. And the best way to accomplish that is to divide by your original denominator. So for this first example, 468 miles in 9 hours. So that's 468 miles in 9 hours. Now, we said we want to simplify, or we want to make this a unit rate. So we want to simplify this until the denominator is 1. Right now, we have 468 over 9. To simplify, we're going to divide by 9 because that is going to make my denominator equal 1. So 9 divided by 9 is 1. 468 divided by 9 is 52. Now, what does this represent? 52 miles in 1 hour. Or we could say per hour. So if we're traveling 468 miles and it takes us 9 hours, we're going at a speed of about 52 miles per hour. Not about, exactly 52 miles per hour. Now, the next one is 180 feet in 12 seconds. So first I'm going to set it up with my units. So 180 feet in 12 seconds. Now, my fraction, my ratio is 180 over 12. So to make this into a unit rate, I'm going to divide by 12. So 180 divided by 12 is 15. 12 divided by 12 is 1. So our answer is 15 feet per second. Okay, now the next question is asking us to find the better buy. So we're looking for which price is going to be the most reasonable, or the cheapest, honestly, because I don't want to pay extra if I don't have to. But they're giving us the original prices for different amounts. Now, it wouldn't really work for me to compare the price for 8 ounces of taco sauce to the price for 12 ounces of taco sauce, because I'm getting way more for 12 ounces. So when we are working for a question that's asking us to figure out what's the better deal or the better buy, we're going to need to find the unit price. Now, the unit price is the price per 1 unit. Price per unit. So our ratio that we're going to set up for the first jar is 99 cents for 8 ounces. When you're doing ounces, be careful that you don't mistake this for a 0 and think that it's 80. And then 12 ounces for $1.69. When you are setting up your ratios, make sure that the units match. So I have price on top, units, in this case it's ounces, on bottom. From here, we are going to simplify both of these into a unit rate. So to do that, I'm going to divide by 8 for this first one. So if it costs 99 cents for all 8 ounces in the jar, if I divide that by 8 ounces, it's 0.12375, but money only has 2 decimal places. We only go up to the hundredths. So the first jar is giving us our taco sauce for about 12 cents per ounce. Now, to figure out what's the better buy, we need to figure out how much per ounce the second jar is charging. So here we're going to divide by 12. And we get 0.1408. So this simplifies to 14 cents per ounce. Now, when I'm comparing them, which would you rather pay, 12 cents per ounce or 14? If they taste the same, the better buy is going to be 12 cents per ounce. So the better buy is 8 ounces for 99 cents. That's our cheaper price per unit. So let's try another one. Now we're being given a sentence and we need to write it as a proportion. The trick for this one is to make sure your units are matched on the same line. So I'm comparing uniforms to players. So I'm going to write that down first so I don't make any silly mistakes. Uniforms on the top, and I will put players on the bottom of the ratio. So this becomes 24 uniforms is to 8 players, as 3 uniforms is to 1 player. If they don't ask you to solve the proportion, then this is your final answer. Now, if we're being asked to tell if the proportions are true, true means they are equivalent. So to find out if they're equivalent, we cross multiply. So first I'm going to multiply 19 times 6, and we get 114. And then I'll multiply the other diagonal, 8 times 14, and we get 112. Now these cross products are not equal, so this statement, or this proportion, is false. Now the next one has some decimals, but we're still going to use cross multiplication just like we did in the last one. So 3.75 times 6. Remember, you are multiplying when you cross multiply. So the product of 3.75 and 6 is 22.5. And then our second cross product, 3 times 7.5, is also 22.5. So because these are equal, this is a true proportion. All right. Now, we may have a situation in which part of our proportion is missing or unknown. When we are solving for an unknown variable in a proportion, we start with cross multiplication. 18 times x is 18x. Then we bring down the equal sign, and then we're going to do the other side. 3 times 30 is 90. So that's how we set up our equation to solve for the unknown. Now we want to get x alone to solve for it, so we're going to divide by 18. That will undo the multiplication and leave x alone. 90 divided by 18 is 5. So our missing unknown number was 5. Now, the next one has a fraction within our proportion, so I'm just going to rewrite this in a way that will be easier for me to work with. And to do that, I'm going to divide 9 divided by 4 to turn it into a decimal. Now that I've set up my proportion with a decimal, which will be a little bit easier for me than a fraction, now I cross multiply. So we get 2.25x equals negative 27 times negative 5 is positive 135. It does not matter which diagonal you multiply first. So after I do that cross multiplication, I get x alone by dividing to separate the coefficient from the variable. That leaves x by itself, and then 135 divided by 2.25 is 60. So our answer for our missing number is 60. All right, you guys are doing great. If you need to pause the video and take a little brain break, go for it. But we're going to continue now with some word problems. 1 bag of pesticide covers 4,000 square feet of garden. So that's feet squared. And that's important for me to recognize because when I see feet squared, I know I'm working with area. Now they're asking how many bags of pesticide should be purchased to cover a rectangular garden that is 180 feet by 175 feet. Now, because we're covering a rectangular garden, here's our garden, we need to cover all of the grass and flowers in the garden. So that's area. My other clue that I needed to find the area was that they said square feet. So before I can set up my proportion, since this measurement is already in square feet, I need to find my area so that I can compare square feet to square feet. So first I'm going to label my diagram 180 by 175, and then my area is length times width. So in this case, that would be 180 times 175 times 175, and we get 31,500 square feet. Now that we have that information, we can set up our proportion. So 1 bag of pesticide, so bags is our first unit, covers 4,000 square feet. So square feet will be the second unit. Now when we label our proportion, 1 bag covers 4,000 square feet. So how many bags means my variable needs to go on the line that I'm putting my bags on. So the X will go on top because that's where the bags are. I want to find how many bags should be purchased to cover my rectangular garden, which we just figured out was 31,500 square feet. Now that we've done that, we can cross multiply. So we get 4,000 X equals 31,500. Once we divide by 4,000, we get X equals 315 divided by 40, 7.875. But we're purchasing an actual item. So I want you to imagine going to Home Depot in their garden section, going up to the cashier and saying, hey, can I buy 875 thousandths of a bag of pesticide? They're going to be super confused. So when we're purchasing something like a bag of pesticide that we can't split into smaller units, we have to round up to the next whole bag. If I buy just 7 bags of pesticide, I won't have enough for my whole garden. So I'm going to need to buy 8 bags. I'll have a little extra left over, but it's better than not having enough. All right, now on a road map of Texas, 75 hundredths of an inch represents 80 miles. Find the distance, so that's what I'm going to be trying to find. X will represent distance from Houston to Corpus Christi if the distance on the map is about 2 inches. So let's set up our ratio. First, I look at my units. We've got inches and miles. So inches over miles. Now, the info they gave us, our first rate is 0.75 over 80. 75 hundredths of an inch over 80 miles. Now we're going to set that equal to our other proportion. The next piece of info they gave us was that the distance on the map is 2 inches. Now, I want to be very careful that I set this up correctly. So it's a good thing I labeled my proportion first because then I can easily see, all right, inches I need to put on the top. And then that means miles will go on the bottom, but that's what they're asking us to find. So that will be X. Now that we've set up our proportion, we can solve for X. So we get 0.75x equals 160. Divide by 0.75. Get X alone. And we get 213.33. But I need to label it. So I have to ask myself, was this inches or miles? Well, the X was on the miles line, so this is 213 miles. Now this one we can have a portion or a fraction of a mile, a decimal here, because miles are something we can measure in increments. All right, now square roots. These you're doing pretty great with, so we're going to run through these. Square roots, you want to think about your fact families and your multiples. So when I see the square root of 64, I want to think which number can be multiplied by itself to equal 64. And if I'm not sure, I can go down my list. I know 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64, and that's what we're finding the square root of. So the square root of 64 is 8, because 8 times 8 equals 64. Now 144. It's a lot bigger than 64, so we can start at 8 and go from there. 9 times 9 is 81. 10 times 10 is 100, so a little closer. 11 times 11 is 121, almost there. 12 times 12 is 144. So the square root of 144 is 12. Now, when we have a fraction that we're taking the square root of, we're going to look at that as two separate square roots, the square root of 4 and the square root of 25. The square root of 4 is 2. The square root of 25 is 5. So we get 2 over 5. For the next fraction, 1 over 100, we're going to split this up, the square root of 1 and the square root of 100. The square root of 1 is 1. The square root of 100 is 10. So 1/10 is our square root of the fraction. Now the last skill that we will see on the test will be a little Pythagorean theorem. We've learned that the Pythagorean theorem states that a squared plus b squared will equal c squared in a right triangle. Now, in our right triangle, we've learned that there has to be a right angle. The sides that are touching or attached to the right angle, those are called legs. And the side that's across from the right angle, that's always going to be the longest side, and we've learned that's the hypotenuse. Now, when we're talking about Pythagorean theorem, our legs will be A and B. It does not matter which is which. And the hypotenuse will always be C. When we are trying to find a missing angle, we can plug in the information missing side, we can plug in the information they give us for the existing known side lengths, and then we can use our equation to find the unknown length. So here they're telling us the first leg is 6, the second leg is 8. And I know my legs are A and B. So if I'm using the equation, a squared plus b squared equals c squared, I'm going to plug in 6 for A, 8 for B, and c is what I'm trying to find, so that's going to just stay c squared. Now 36 plus 64 equals c squared. 36 plus 64 is 100. But I'm not done even though c looks like it's alone, because this little exponent, although it's little, it does matter. So we have to get rid of that. Now, right now the exponent is telling us that we're squaring c. So to undo a square, we take the square root. And we have to do that to both sides. So when I take the square root, I get 10 equals c. So this missing side is 10. Now, if you thought this was your answer, I want you to think about reasonability. These two legs are 6 and 8. Does it seem reasonable that the longest side would be way, way bigger? It's not impossible, but not very likely. So 10 is a much more reasonable side length. Let's do one more like this. So this time they've told me that my legs are 3 and 4. So I'm going to plug that into our equation. A squared plus b squared equals c squared. So this will be 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 9 plus 16 is 25. And then we take our square root to get c alone. That cancels out and leaves c by itself. And the square root of 25 is 5. All right, so that is the end of our review, but I do want to go over a little Pi Day trivia. Now, the following facts may or may not make an appearance on tomorrow's quiz. Pi Day is celebrated on March 14th. That represents the 3.14 that we know of as pi. So that's why we celebrate on March 14th, because when we write the date 314, it matches the abbreviation or the approximation for pi. The next fact, Einstein. Good old Albert Einstein is a mathematician and physicist who just so happened to be born on Pi Day in 1879. I think that's a pretty cool coincidence. The pyramids of Egypt are believed to be built on the principle of pi, which is an interesting fact because pi refers to circles and the pyramids are pyramids. But if you look at the measurements for the pyramids, the ratios there roughly estimate to the ratio of pi. So it's believed that the ancient architects who built the pyramids used some form of the principle of pi in their design. And the last fun fact that you may or may not see, within the first million digits of pi, so 1 million numbers, in all of those numbers, the sequence 1, 2, 3, 4 does not appear. That is pretty surprising because out of 1 million digits, there's a good chance that somewhere in that list of numbers, 1, 2, 3, and 4 are going to show up in this order. But pi, being the special number that it is, does not have any occurrences of 1, 2, 3, 4. All right. So with that final fun fact, that concludes our review for the Chapter 6 test. Please continue studying on your own if there is anything that you're unsure about. But I look forward to seeing all of your hard work and effort pay off on this final test of the quarter. Have a great evening, and I will see you all in class. Bye.